In this beginner level course for Linux, so far we have gone through quite a few details with respect to Linux shell commands. In this sectional module, we'll actually go through the details about copying files and folders between multiple systems using SCP. We are talking about multiple systems and hence we need to have multiple systems set up. To make sure we understand how to copy files and folders between multiple systems using SCP, first we'll start with provisioning multiple EC2 instances from AWS. If you are not sure about AWS, you have to go through the sectional module related to getting started with AWS, understand some of the key concepts, then you have to go through the lecture which actually covers how to provision multiple EC2 instances from the perspective of copying files and folders using SCP. Keep in mind that the EC2 instances that are provisioned from AWS have Ubuntu 20.04 on them. Once we go to the details about provisioning EC2 instances, then we'll actually go to the details about connecting to these EC2 instances from tools such as Windows PowerShell and also WSL. Windows PowerShell also comes with SSH setup. You should be able to use Windows PowerShell directly to copy the files. However, I'll be demonstrating using Ubuntu, which is set up using WSL on Windows. Then we'll actually take care of preparing the datasets to explore copying files. The datasets might be set up on our client and also on the remote machines just to make sure we understand the process of copying the files between the systems. In this case, I'm not talking about only from client and the remote machines. It can be between the remote machines itself. Once we get an overview of SCP, we'll actually perform tasks to copy files and folders between multiple systems using SCP. By now, you should be having a fair understanding about SCP command. However, you need to use SCP command along with other commands to tune the performance of copying the files between the systems. We'll understand how to copy tarball or zip file using SCP between Linux servers. If you have too many small files that are supposed to be copied, one of the technique to tune the performance of SCP is by building a tarball or zip file, then taking care of SCP. It will definitely improve the performance of copying too many small files. Once we understand how to copy tarball or zip file with too many small files using SCP, then we'll actually go to the details about copying the files from one machine onto multiple machines using parallel SCP. If you go to the details about SSH, which we have covered earlier, you should have parallel SSH setup. Along with parallel SSH, you will also get parallel SCP. You should be able to use parallel SCP to copy the files from one machine onto multiple machines in parallel. Once we go through the details related to using parallel SCP to copy files from one machine to multiple machines in parallel, we'll also see how to use multiple threads to copy files from one machine to another machine. First, we'll explore something called as nohup. It will facilitate us to submit commands in the background. Once we go to the details related to nohup, we'll actually issue multiple SCP commands between one system to another system using nohup, and we'll run multiple SCP commands in parallel. It will take care of tuning the performance of SCP when we have to copy several datasets onto the remote machine. Instead of copying using one SCP command, we should be able to use multiple SCP commands to tune the performance. As part of this sectional module, we'll not only see basic usage of SCP command from the perspective of copying files and folders, we'll also see some of the common techniques we use to tune the performance of SCP to copy files from one system to another system or one system to multiple other systems. Make sure you go through each and every lecture in this section and understand each and every concept and command so that you use these techniques whenever work as part of the projects. It will definitely boost your productivity over a period of time. As part of this sectional module, we are going through the details related to copying files between Linux systems. In this case, we'll be provisioning two EC2 instances from AWS so that we have multiple systems to explore all the details related to copying files between Linux-based systems. Also, we'll be copying files from our PC, which is either Mac or Linux on top of Windows onto the systems, and also vice versa. The source is nothing but our PC. The target will have two systems. They are nothing but two EC2 instances from AWS. That being said, let's go ahead and provision two EC2 instances with Ubuntu 20.04 with the copy demo as name. I am already in EC2 console. As part of the EC2 console, you should be able to click on launch instance in EC2 dashboard. In EC2 console, I'm in EC2 dashboard. You can see here we have launch instance here. I'm going to use this to launch instance. It will take us to the launch instance wizard. Now we should be able to specify the name. The name is nothing but copy demo. When it comes to the operating system, it is nothing but Ubuntu. I'll be using Ubuntu 20.04. Let me pick Ubuntu 20.04. Even you can use other versions of Ubuntu as well. copying files will not differ based on the version of Ubuntu, whether it is Ubuntu 16.04 or 18.04 or 20.04 or 22.04, it doesn't matter, it will work as expected. That being said, when it comes to the instance type, I'll be using t2.micro. These are free tier eligible. When it comes to key pair, it is nothing but GS demo. When it comes to storage, I'll be configuring 16 GB. 8 GB might not be good enough. Let's make sure to have at least 16 GB. Now we should be able to increase the number to 2. You can review the details here. The operating system is nothing but Ubuntu 20.04. Server type is nothing but t2.micro. We are going to create a new security group. The storage volume is of size 16 GB. We are provisioning 2 such instances. Now we should be able to click on launch instance. It will take care of creating the 2 instances. Once the 2 instances are created, we should be able to use SSH to connect to the instances. We have to use gsdemo private key file, which is nothing but gsdemo.pem, which is already downloaded when we have created EC2 key pair earlier. That being said, let's wait until the instances comes up, then we'll take it further. At this time, we are going through the details related to copying files between multiple Linux systems. So far, we have provisioned 2 EC2 instances from AWS. Now, let's see how to connect to these EC2 instances using Windows PowerShell. Even though I'm going to recap about how to connect to these EC2 instances using Windows PowerShell, I'll be predominantly using the Linux on Windows to actually connect to these EC2 instances. Also, you can use your Mac to connect to these EC2 instances if you are using Mac. I have already covered those details earlier. That being said, let me launch PowerShell here. I'm in the home directory of the user. Under downloads, I have the gsdemo.pem. Using this pem, I should be able to connect to the EC2 instances. Now let me say cd ... to go to the parent folder of downloads, which is nothing but home directory of this user. Now I should be able to say ssh-i, then downloads. You can hit tab to autofill. Then you can say gsdemo.pem. Then Ubuntu is the user using which we need to connect. At the rate, we need to get the public DNS of the EC2 instance. For that, I should be able to click on it and also click on it to open the details of both the instances. This is related to the first one. Let me select this. This is the public DNS. I have copied. Let me go to the PowerShell in Windows. Let me paste. Let me hit enter. Let me say yes here. It will let us into this EC2 instance. You can see that I'm connected to that EC2 instance. Now I can say exit to come out of it. To connect to the other one, I just have to say ssh-i, downloads, then gsdemo.pem, then Ubuntu, at the rate, the public DNS of the other instance. I can go here, select this, get the public DNS, paste here, hit enter, say yes when prompted. You can see that we are able to connect to this EC2 instance as well. So both the EC2 instances are validated here. As we have successfully connected to these EC2 instances using PowerShell, now let's explore how to connect to these EC2 instances using Linux that is set up on top of Windows using WSL. I'll be using the latter approach to actually demonstrate most of the lectures related to copying files between Linux systems. As part of this external module, we are going through the details related to copying files between multiple Linux systems. So far, we have gone through the details related to provisioning multiple EC2 instances from AWS and also connecting to EC2 instances using Windows PowerShell. Now, it is time for us to understand how to connect to these EC2 instances using Linux on top of Windows, which is set up using WSL. First, let me connect to the Linux that is set up using WSL. You can run WSL-L-V to list the current Linux-based systems that are set up using WSL. There is only one and it is default, and hence we should be able to say WSL to not only start this Ubuntu-based environment on Windows, but also to get into it. It will just take some time to start this Ubuntu-based system in Windows, and then we'll be able to connect to that instance as well automatically. You can see that I am connected to this instance. By default, it have taken us to this location. This is nothing but Windows home directory. Now you can actually say cd downloads. Now you should be able to run ls-ltr on the same downloads folder which you have seen earlier using PowerShell. Now we are actually seeing using WSL. In this case, WSL is nothing but Linux, and hence we have to use ls command to list the files. On PowerShell, we should be able to run dir command to list the files. You can see the list of files here. We have gsdemo.pem under downloads folder. Let me go one level up. Now let me say ssh-i downloads. I'm using relative path. this contain gsdemo.pem, then Ubuntu. Let me go to the AWS console. Then let me pick the public DNS of the first EC2 instance. Let me paste here. Now it is pasted. Now let me hit enter. Let's see whether we'll be able to connect or not. You see, it is failing by saying bad permissions. Let me explain why it is failing with bad permissions on Linux, but why it is working on PowerShell. Now, if I go to the downloads folder, then run ls-ltr. When it comes to the permissions on gsdemo.pem, it have these permissions. It is nothing but 777. Because these files are exposed from Windows onto this Linux-based system, by default, the permissions are like this. However, if I exit from here, then if I go to downloads folder from PowerShell, and then if I say dir, you see the mode is different. In Windows, the permissions are different, and in Linux, for the same file, the permissions are different. In this case, as there is 777 on gsdemo.pem, it is not working. So how to fix it? Let me go back to the WSL. Now, what I'll be doing is I'll be copying this gsdemo.pem to .ssh folder on this Linux-based system. Let me see if I have .ssh folder or not. For that, I should be able to say ls-altr / which is nothing but home directory in Linux. Hit enter. You see there is .ssh folder. If you don't have .ssh folder, just run ssh keygen. It will take care of creating the .ssh folder for you. The command is nothing but ssh keygen. It will take care of creating this .ssh folder. You just keep on hitting enter until the command is successful. That being said, I will be copying this file into that folder. The file is nothing but gsdemo.pem. I can actually say cp gsdemo.pem / for home directory /.ssh. Now let me hit enter. Let me say cd. Now let me say ls-ltr /.ssh. You can see gsdemo.pem. Still it might not work. Let me try using this pem file and see if it works or not. I just have to hit up arrow to go to that ssh command. Here, instead of saying downloads, I just have to say .ssh. I'm already in the home directory of the user, and hence I should be able to say .ssh directly, but typically I use this approach, /.ssh, hit enter. The reason why I use /.ssh is because this will be running from anywhere in the file system. We need not be there in the home directory of the user. Now, still it is complaining, saying bad permissions. We just have to have either 400 or 600 on this file. As of now, the permissions are 755. With the 755, we will not be able to use this private key file to connect to the remote Linux-based servers via SSH. Now, what we are supposed to do is we have to run chmod command by saying chmod, then 400 /.ssh, then gsdemo.pem. Now, the permissions are changed. Now, let me go back to this command. Let me run it. This time, it will work without any issues. So we are able to connect to the first EC2 instance from Ubuntu that is set up on top of Windows using WSL. Now let's try with the second one. I just have to replace this public DNS with the public DNS of the second instance. Let me go back here. Let me go to this tab. Let me click on this to copy. Now let me paste here. You can see that this is a different public DNS than what we have used earlier. Now we can hit enter. It will take care of connecting to the EC2 instance once we confirm. You can see that we are able to connect. This is how you should be able to connect to EC2 instances using Ubuntu-based systems that are set up on Windows via WSL. If you are directly using Ubuntu-based systems, you just have to start terminal, make sure you have the PEM file. Using that PEM file with the right permissions, you will be able to connect to the remote machines without any issues. As part of this sectional module, we are going through the details related to copying files between multiple Linux systems. In that process, so far we have provisioned 2 EC2 instances from AWS, and also we have seen how to connect both from Windows PowerShell as well as from Linux on Windows. As part of this lecture, we will be going through the details about preparing the datasets. However, let's make sure we come out of the EC2 instances onto the system from where we wanted to copy the files. If you are using Mac, you can use the same approach as we have seen with Linux. That being said, as of now, I am in my Linux-based system on top of Windows. I came out of the EC2 instance. I can confirm by saying ls-ltr and also hostname -f. This is the host name of this system. And also if you look at the output of ls-ltr on home directory of this user, there is a folder called as data. First, let me delete this data folder and recreate it using the tarball which I have used for the backup. The reason why I'm doing this is because data might have got corrupted over a period of time. I just want to make sure I have clean data folder. For that, I'll be using this tarball to restore the data folder as it was earlier. Now I can say tar xvf or -xvf, then data.tar. It will take care of creating the data folder for us. If you look at the files in this, there are quite a few files which are not compressed, and there are quite a few files which are compressed as well. To review the details, we can actually go to the data folder. Let's say ls-ltr, we can actually see all the folders and file in this. Now we should be able to say find, then .-name star.gz. It will give us all the files which are compressed using gzip algorithm. We can also try searching for .zip files. Let's see if we have any .zip files. There are no .zip files. Now, to make sure we have appropriate datasets to explore all the important concepts related to copying files between the servers, first I'll be uncompressing all these files. In this case, I can actually uncompress using gunzip command because these are nothing but gz files. We should be able to automate the process of unzipping all these files in one shot using this approach. Let's say find, then .-name star.zip, then awk, then we can actually say print gunzip $1. Let's see if it will print as expected or not. Actually, it didn't print because the extension that is used to search for the files is not right. I have to use gz. So let me say gz here. Now you can see the commands gunzip blah blah blah. Now we should be able to pipe to bash to run all these commands to unzip or uncompress all these files. You can see that it is running. It will take a little bit of time to actually unzip all these files. Once it is done, we'll actually compare the size of the folder with data.tar. Before uncompressing, both are same. After uncompressing, this folder will be much larger in size compared to data.tar file. Now all the files are uncompressed. You should be able to say du-sh dot to get overall size of this folder. Now it is of size 3.1 GB. However, if you look at the details about data.tar file, it is only 631 MB. You will understand why I have unzipped all these files to copy the files from this machine onto the remote machines very soon. So don't worry too much if you are not sure about why we are uncompressing. For now, just go ahead and uncompress all these files so that we have enough datasets to explore all the important concepts related to copying files between the Linux-based systems. As part of this sectional module, we are going through the details related to copying files between multiple Linux systems. So far, we have provisioned a couple of EC2 instances, and also we have prepared datasets to explore copying files. Now, let's get an overview of SCP for secure copy between Linux servers. The command is nothing but SCP. You can say SCP -help. When it comes to SCP, it stands for secure copy. It works on top of SSH. Without SSH, you will not be able to use SCP. There has to be SSH daemon running on the remote servers to use SCP to copy files onto the remote servers, and also vice versa. SCP can be used to copy files from this Linux-based system onto the remote Linux-based systems or Unix-based systems, and also you should be able to copy the files from remote systems onto this system as well. Let's see a simple example, then we'll take it further. In this case, I'll be creating an empty file. Let me say touch scp demo to actually create empty file. Now scp demo is created. Now let's see how we can copy this file onto the remote machine. To actually get the usage, you just say scp and hit enter. You don't need to say -help. When you actually say -help, it is actually complaining saying unknown option. That being said, it is pretty straightforward. If you have to use private key, you have to say scp-i, then you have to pass the private key file name, which is nothing but ~/.ssh, then gsdemo.pem in our case. Then we have to specify the source. In this case, the source is nothing but a local file on this machine, and hence we can say scp demo. This is the file which we are trying to copy. Then we have to specify the target details. When it comes to target details, we have to start with the username. Then we have to specify the public IP or DNS. Between username and public IP or DNS, we need to have @. So username @remote host, then colon. Then you have to specify the location in the target system. If you wanted to copy to home directory, then you can actually specify tilde and it will copy to the home directory. If you wanted to copy to temp folder, you can actually specify the temp folder like this. Under the root file system, typically we will have temp folder. We should be able to use temp folder as well. We just have to say /tmp like this. Now scp demo file will be copied into this location with that name. If you want to change the file name, you can also specify the target file name. Let's say scp demo target. This is how you should be able to specify the target details. Now, when it comes to the username for our EC2 instances, the username is nothing but Ubuntu. I'll be using the public DNS of the first EC2 instance. Let me delete remote host here. Let me go back to the AWS console. Let me go to the first tab. This is the public DNS of the first EC2 instance that is created earlier. I have to paste it. Then we can say colon, target location is nothing but /tmp/scp demo target. Scp demo file will be copied as scp demo target on the target machine. Now let me hit enter. The file will be copied for us. You can see that the file is copied. You can validate by using ssh, then -i /.ssh gsdemo.pem. Then you have to specify the target details. Let me copy this and then let me paste here. Now I am connected to that EC2 instance. Now I can say ls-ltr/tmp. You can see the file scp demo target. Instead of getting into the machine and then running ls-ltr, we can also use this approach. After specifying ssh, we can actually use double quotes like this, then say ls-ltr/tmp, then hit enter. You should be able to review without logging in into the EC2 instance or any remote machine. So far we have successfully copied a file from local machine onto the remote machine and also validated. Now let's also see how to copy the file from remote machine to local machine, and then we'll also see how to validate. In this case, I'll be just using scp command to copy the file from the remote machine onto this machine. Then we have to specify the SSH key details. The SSH key details are nothing but ~/.ssh gsdemo.pem. Once we specify the PEM file name, we have to specify the remote machine details. In this case, the remote machine details are nothing but these ones. We just have to use the username @hostname. Let me copy into the buffer. Let me paste here. Now we have to specify the location of the file on that remote machine. It is nothing but /tmp/scp demo target. However, we need to have colon before passing the location. After specifying the colon, we have to say /tmp, then scp demo target. Now I would like to copy this file on this local machine under /tmp with the same name, and hence I can just say /tmp. As I would like to use the same name, specifying the name of the file is optional. Now let me hit enter. It will take care of copying this file on this machine to /tmp. You can validate by saying ls-ltr/tmp. You can see scp demo target file here. This is how you can get started with SCP. You will see quite a few examples to understand SCP to copy files from one server to another server via SSH. That being said, let's clean up the files which are actually added for the demo. Let me say ls-ltr. We have this SCP demo file on this machine. Let me say rm and then let me delete this file. Let me also say rm/tmp, then scp target demo or demo target. Even that file is deleted. Now let's delete the file on the remote machine as well. For that, I can use this command as a reference. Then replace ls-ltr with rm/tmp, then / then scp demo target. Now let's hit enter. The file is deleted. You can run ls command once again on the remote machine using this one to confirm whether the file is deleted or not. Now there is no such file, which means the file is successfully deleted. This is how you can actually get started with SCP. Let's go ahead and take care of executing quite a few tasks to understand SCP in detail. In the process of understanding copying files between multiple Linux systems, at this time we are actually talking about SCP. After setting up a couple of EC2 instances, we have set up datasets and also we got an overview of SCP. Now let's go ahead and see how we can copy data.tar from this machine onto the remote machine. I'll be using data.tar first. To copy data.tar to the remote machine, I should be able to say scp-i ~.ssh, then gsdemo.pem. Then we have to specify the file name on the local file system because we are trying to copy the file from local file system onto the remote machine. Now we have to say Ubuntu, which is nothing but user @ then the public DNS of the remote machine, which is nothing but this one. I'm copying it to the first EC2 instance that was created earlier. We can paste, then we can say colon, then slash, then tmp. Now data.tar will be copied to /tmp folder. If you don't want to copy to /tmp, instead if you want to copy to home directory of the user Ubuntu, then you can actually specify tilde. Now the data.tar will be copied from local file system onto this remote machine with the same name. I haven't specified the name on the remote machine, and hence it will use the same name. Now let's see how long it will take to copy this 630 MB data.tar file from this Ubuntu based machine onto remote EC2 instance. We'll wait until it is done, then we'll take it further. As of now, the ETA is 21 seconds. It is actually reducing over a period of time. We will understand how long it took very soon. If you look at the speed, it is actually copying with 15 Mbps. In your case, the speed might be relatively low depending upon where you are actually running this command from. In my case, I'm actually using a powerful machine on Azure cloud, and hence I'm getting a decent speed. Now you can see that it took 41 seconds to copy data.tar onto the remote machine. You can validate whether it is copied or not by using pssh command. You can actually copy these details here. The PEM file is nothing but this one. Then the connection details for the remote server are nothing but these ones. I have copied these details and pasted here. Now I can say ls-ltr, hit enter. It will take care of running this command on the remote machine. You can see data.tar here. You can also compute the size of the file by saying du-sh data.tar, or you can also say ls-lhtr to actually get the size in MB. When it comes to data.tar, it is of size 631 MB. Also, we have data folder. When it comes to data folder, the size is more than 631 MB. So in this case, I'm saying du-sh data. It is actually 3.1 GB. It is because we have uncompressed all the files after untarring this tarball to restore this data folder, and hence size is bigger. Now we have to copy this entire folder. We will see how to copy this entire folder as part of next lecture. As of now, we have seen how to copy the files. Using the same approach, we will not be able to copy the folders. For example, if I say scp, then -i, then ~//gsdemo.pem, and then if I just specify the folder name here, it will not work as expected. It will fail saying data is not a regular file. We need to add additional control arguments to copy the folders via scp. However, let's review the documentation with respect to scp using man. Man stands for manual pages. In this case, there are quite a few control arguments which can control the behavior of scp command. One of the important control argument is nothing but -C. -C will facilitate you to compress while copying the file. When I actually use scp to copy data.tar, it took 40 seconds. Now let's see how long it will take when I use -C. Let me come out of this here. Now I am outside the man scp command. Now instead of saying scp-i blah 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 with data.tar, I will also add additional control argument. It is nothing but -C. I'll be adding the additional control argument here after specifying the key. Now let me hit enter and see how long it will take to copy data.tar onto the remote machine. Earlier it took 41 seconds, now it took 38 seconds. Now let me do one thing. Let me actually build a new tarball using this data folder which is of size 3.1 GB, and then we will actually try copying this file with -C and without -C. We will see if there is any difference in the performance. That being said, to build the tarball for data folder, I can use tar command like this, tar-cvf. Then I should be able to specify the tarball name. Let's say data_uncompressed.tar. Data is the folder which is supposed to be converted to the tarball. Let me hit enter. It will take some time to build the tarball. Let's wait until tarball is completely built, then we'll take it further. Now the tarball is built successfully. We should be able to validate by saying ls-lhtr. When it comes to data_uncompressed.tar, it is of size 3.1 GB. Now let's try copying using scp onto the remote machine without compressing by using -C. The command which we can use for the reference is nothing but this one. I can say scp-i. Then when it comes to the name of the file, it has to be data_uncompressed.tar. It is autofilled. Now I can hit enter. I have hit tab to actually autofill. Now it is actually copying this data_uncompressed.tar onto the remote machine. As the file size is 3.1 GB, it will take some time. Let's wait until it is done. Then we'll actually see how long it took to copy this 3.1 GB file. Now the file is copied successfully. You can see that it took 3 minutes 37 seconds. You can validate by running ls-ltr command via ssh. Let me go back to that ls-ltr command. Let me say ls-lhtr so that we actually see the size of the files in a readable format. You can see that data_compressed.tar is copied successfully and it is of size 3.1 GB. It took 3 minutes 37 seconds to copy this file without enabling the compression. Now let's enable the compression and see how long it will take. I'm using the same command which we have used earlier. In this case, instead of just saying scp-i, I'll be adding -C as well. Let me say -C, then data_compressed.tar, then the target details. Now let's hit enter. Let's see how long it will take this time. You can already see that it is faster in performance because the ETA is 2 minutes 21 seconds compared to what we have seen earlier. As part of the previous run, when we have started, it have shown close to 4 minutes as ETA. This time it have shown only 2 minutes 20 seconds as ETA, which means this time it is going to be copied faster. However, when it comes to the speed, it is lesser. It is because of the fact that it have to compress while copying the files. Overall throughput is reduced here, but still it might complete faster. Let's wait until it is completely executed, then we'll take it further. You see here, total copy time is 2 minutes 54 seconds. The reason why it took a little bit more time than ETA was because in between the throughput have reduced. Now, this is how you can actually speed up the performance by using -C, which actually compresses the data while it is being copied from source to the destination. If you recollect, I have performed SCP 4 times. Let me say history pipe grep SCP. Let me hit enter. You can see that I have ran SCP 4 times. This is the first time I have copied. I have copied data.tar which contain all compressed files. It got executed in 40 seconds. Then we have used -C, where on top of this data.tar, where majority of the files are compressed, still it is a little bit faster. It is because there are quite a few files in this tarball which are not compressed. The compression have improved speed little bit. Then we have created a tarball with uncompressed files. Then we have attempted to copy the uncompressed tarball where all the files are unzipped or uncompressed. It took almost 4 minutes. Then we have used -C to actually copy this uncompressed tarball. It actually compresses while copying. It took 2 minutes 54 seconds. Now I leave it to you to actually think and understand why using SCP leveraging -C is faster compared to using SCP without having -C. Think about it. Think from the perspective of networking concepts, and probably you might get some insights about why compression is actually speeding up the performance. That being said, as we have understood how to copy the files, let's also focus on how to copy the folders as part of the next lecture. As part of the sectional module, we are going through the details related to copying files and folders between multiple systems. In the previous lecture, we have seen how to copy files using SCP between multiple systems. We have attempted to copy the files from Linux-based source to the target which is provisioned from AWS. Even target is set up using Linux only. That being said, now let's go to the details related to copying folders from the source to the target, or even vice versa using SCP command itself. These are the SCP commands that are used to copy the files. The same approach will not work for folders. If you try to use this command, it will fail. In this case, data is the folder in the home directory of this user. Let me copy this. Then let me say ls-ltr. You can see data folder here. Now, if you paste this command, which is typically used to copy the files, it will fail because we are trying to copy the folder. Even when we try to copy from the remote machine to here, if it is a folder, it will complain with a similar error. You can see it is saying data is not a regular file. In this case, to copy the folders, which means all the files and folders recursively in a given folder, we have to add -r. -r stands for recursive. Now we can hit up arrow, then go before data. Before data, we can enter -r like this, or we can type -r like this, and then you can hit enter to run. Now the folder will be copied recursively to the target. However, it will take quite a bit of time because each and every file have to be copied onto the remote machine. There will be overhead for not only the overall size of the data folder, but also the number of files in the data folder. You can see that it is taking quite a lot of time, and also ETA is related to a given file that is being copied at that time. It is not related to the complete folder. Let's wait until it is run, then we'll take it further. I'll not let everything to complete at this time. We will actually kill it in between, then we'll take it further. Still it is running. Only one file is copied so far. Now there are quite a lot of other files which are supposed to be copied. You can see that it is going to take more than 1 minute. deckofcards.tar is a big file. That being said, now I'm killing it. At this time, as part of this data, we haven't compressed any files. The overall size of data folder is nothing but 3.1 GB. So it will take quite a lot of time to copy all these files and folders that are there as part of data. To speed up, you can use -C. -C is for compression. Let's say -C. I'm entering -C before -r. You can place them in any order. Now let me hit enter. This time the files will be compressed while copying. Once the files are copied to the target, they will be uncompressed as well. Now you see it is taking a little bit less time compared to uncompressed copy. Let's wait until the copy of this file is done. Then I'll kill and then I'll take it further. Now let me kill it. You can see that it took only 23 seconds with -C, where files are being compressed during the copy, whereas when -C is not used, it took 43 seconds. This is how you should be able to copy the files in a folder recursively using -r option. That being said, let's actually produce too many small files and see what happens when we try to copy all those files in one shot. Let me scroll up here. Now let me actually create a folder called as pscp demo. Let me get into this folder. Now let me touch so many small files. I have already used touch in the past, and hence let me say history, then grep touch. I can use these commands to generate too many small files. Let me first run this. It will take care of creating small files for 2022 between January to December from 1 to 28 days. Let me copy and paste it. Now let me make sure I add files up to 30th for all the months except for February. Now let me add 31st day for all those months where we have 31 days. Now all the files are ready. We should be able to say ls-ltr. You can see there are so many files here. You can actually say ls-l or ls-ltr, then wc-l. You can see that it have returned 376, which means there might be some files where the names are not right. However, you can ignore it. We have so many small files or so many empty files. Let's see how we can copy all these files into the remote machine, and then we'll actually talk about some of the side effects copying too many files. Let me go to the home directory. In this case, I should be able to use same scp-r command. -C is not relevant because these files are anyway empty. In this case, I will just use home directory at the destination to copy these files to. When it comes to the folder which contain these files is nothing but scp demo. I am removing -C. Whether you have -C or not, it doesn't matter. Now let me hit enter. Now the files are being copied. You see, at a time it is only copying one file to the target. As it is copying only one file to the target and getting the response from the target, and then as it is trying to copy the next file, it is taking almost a second for each and every file. If it takes a second or half second for each and every file to copy 376 file, if it is half second per file, then it is almost 3 minutes. If it is 1/3 of a second, it is almost 2 minutes. It took more than 2 minutes to actually copy the entire folder to the target. Instead of copying the folder like this, we should be able to build a compressed tarball for the folder on the source. Then we should be able to copy to the target. Then we should be able to uncompress and untar. That will actually speed up the performance considerably. Let's go to the details as part of the next lecture. As part of the sectional module, we are going through the details related to copying files and folders between multiple systems. In the previous lecture, we have tried copying a folder called as scp demo. This is the folder which we have tried copying. If you look at the size of this folder, it is only few bytes or few kilobytes. You can see here, the overall size of the folder is nothing but 20 kilobytes. If you look at the number of the files, it contains almost 375 files. Let me say scp demo, then star.log, then wc-l. I am piping the output of ls-ltr command to wc-l to get the number of files. You can see that we have 375 files with the log extension in this folder. When we try to copy these 375 files of size 20 kilobytes, it took almost 2 minutes. It is because it has to copy one file at a time. It can only copy the next file after getting the feedback of the prior file. Now, one of the ways to tune the performance of copying many files is to build the tarball and then performing the copying. However, when we copy the tarball to the target also will have tarball. The target will not have the folder itself. To make sure we have the folder structure as is in source, we need to make sure the tarball is untarred in the target. Let's go to the life cycle of addressing the issue of copying too many small files using tar and then scp and then tar. In this case, I should be able to build the tarball using tar-cvf or czvf. If you want to compress while building the tarball, you can also include z between cv and f. Now I should be able to specify the tarball name. In this case, scp-demo.tar. I'm not compressing because the size is not that big. Now I should be able to specify the folder which is supposed to be used to build the tarball. Now the tarball is built. You can say ls-ltr. You can see the tarball details here. Now let's get the reference of our scp command which we have used earlier. Let me say history, then grep scp. Now let me use this one. I have copied and then pasted here. Now let me replace -r scp demo with scp demo.tar. Let me delete here. Then say scp demo.tar. Hit enter. Now tarball will be copied onto the remote instance. Now it is copied. We should be able to validate by saying ssh, then -i, then ~/.ssh, gsdemo.pem, then the connection details, which are nothing but these ones. I have copied and then pasted. Then I should be able to say ls-ltr in double quotes. Now we should be able to see the file. You can see scp demo.tar here. Now we should be able to untar by using appropriate command. There is a error. The reason why we are seeing the error is because there is a typo in PEM. Let me remove R here. Now let me hit enter. Now we should be able to see the details. You can see the tarball here. Let's untar it to make sure we get the original structure. Before untarring, I would like to remove this folder. The folder is nothing but scp demo, which is already there in the target. For that, I should be able to say rm-rf scp demo. Now the folder is deleted. You can validate by running ls-ltr command once again. Now you can see the tarball, but there is no folder. Now you should be able to untar by saying tar, then xvf. As this is not compressed tarball, xvf is good enough. If it is compressed tarball, we have to use xzvf. Then I should be able to specify the tarball name, which is nothing but scp demo.tar. Also, I need to make sure I have hyphen before xvf. Let me add hyphen here. Now I should be able to hit enter. Now the tarball will be untarred in the target. We should be able to validate by saying ls-ltr on target. You can see the folder. Now the folder is as per the source. This is how you should be able to take care of copying the folder with too many small files from source to target by tarring in source, then copying to the target, and then untarring in the target. You can also include these three commands in a script and you should be able to run it as a script. Now let me say history. I should be able to get all the commands. You can see all the commands here. Now I should be able to copy these lines. Let me copy these lines into a program file. I have copied these lines. Now let me say vi myscp.sh. Now let me paste here. It is not actually copying properly. There are quite a few reasons for that. Let me come out of it without saving. Now let me say nano myscp.sh. Now let me paste. Now the lines are copied properly. I just have to clean this up. We need to remove these line numbers. Let's remove the line number. We don't need this line at all. So let me delete these two lines completely. After creating the tarball, we need to make sure that tarball is copied to the target. This is the line which can be used to copy the tarball to the target. Then we need to make sure it is untarred in the target. So I should be able to clean up these 2 lines, or actually these 4 lines. Let me clean up these 4 lines, and then let me keep the tar xvf command, and then we will take it further. Now I have cleaned up this file. Let me come out of it by saving it. Now it is saved. We can say cat myscp.sh. You can see all the 3 instructions. First, let's run this to delete from the target. I'll be using rm-rf on scp demo star, which means both the tarball as well as folder will be deleted. We can validate whether both of them are deleted or not by using ls-ltr command. Let's run this ls-ltr command. We should not see both folder as well as the tarball. You can see that both folder as well as tarball are gone. Now I can actually say source myscp.sh. Hit enter. Now tarball is built. Tarball is being copied. Now tarball is untarred in the target. You should be able to validate by running this command. You can see both tarball as well as folder here. In case if you wanted to delete this tarball, you can update the script and you should be able to delete the tarball on the remote machine once it is untarred. The overall time to actually tar, then copy, then untar just took under 5 seconds compared to 2 minutes when we try to copy this folder with too many small files using scp command. So this is much faster compared to what we have seen earlier. Make sure you understand the relevance of building the tarball and copying the tarball to the remote machine and then untarring it in case if you have to deal with too many small files as part of scp process. That being said, this is how you should be able to copy the files and folders between the systems using scp. As part of this sectional module, we are going through the details related to copying files and folders between multiple systems using scp. So far, we have seen all the details with respect to scp from the perspective of copying files as well as folders. Now, at times, we might have to deal with multiple systems. We might have to copy the same files into multiple systems from the source. For example, if you look at this diagram, we have provisioned 2 remote servers from AWS. Now, we might want to copy the data folder into both the instances. Instead of copying into one system at a time, we should be able to leverage parallel based approach and we should be able to copy into both the systems at a time. For that, we should be able to use parallel SSH based approach. Already we have set up parallel SSH on this. You can actually validate by saying parallel -SSH, then --help. You should be able to see the usage. When we actually set up a parallel SSH using pssh, we also get additional tools such as parallel SCP. Let's see whether we have parallel SCP or not. Let's say parallel, then -SCP, then -help. You can see the usage of parallel SCP. In Mac, you'll be seeing this as pscp, whereas in Linux, especially Ubuntu Linux, you'll be seeing it as parallel -scp. To make sure we use pscp, whether it is Mac or Linux, we can actually create a soft link for parallel SCP as pscp. Already we have created soft link for parallel SSH as pssh. Let's review the command. Let me say history, then grep, then ln. This is the command which we have used to create soft link for parallel SSH as pssh. Now let's copy this command. In this case, we need to make sure we create the soft link for parallel SCP as pscp. Now this command ran successfully. You should be able to validate by saying ls-ltr/usr/bin/pscp. You can see the soft link here. Now you should be able to say pscp -help, hit enter. You should be able to see the usage of this command. As we have created soft link for parallel SCP as pscp, let's go ahead and use pscp command to copy the files onto multiple systems at the same time. To use parallel SCP to copy the files onto multiple systems at the same time, you have to pass the host names. Either you can pass the host name via file like this. Already we have a file which we have created earlier. It have entries related to both the EC2 instances which we have provisioned, or we can also use -H as we have seen with pssh as part of the demo earlier. So using the file or inline strings, we should be able to use pscp to copy the files onto remote machines at the same time in parallel. As we have the soft link and also the required file with entries, let's go ahead and see how we can use pscp to actually copy the data folder onto both the systems in parallel. However, before going to those details, let's make sure these 2 entries are right. This is the public DNS of the first EC2 instance that is provisioned. Let's go here and validate. You can see the details here, 382.57.115. Let's compare with this. Even this one is 382.57.115, which means it is right. Now let's check the second one. The second one is nothing but 389.163.226. You can see the details here. The second one is nothing but 389.163.226, which means both the entries are right. As we are ready with both pscp as well as the file with entries, let's go ahead and run pscp command to copy the data folder onto both the instances at the same time. As we have successfully set up parallel SCP or pscp to copy files to multiple systems in parallel, let's make sure to clean up the files that exist already in the target systems. For that, we'll be using pssh or parallel SSH. When it comes to using parallel SSH and parallel SCP, the syntax and semantics are same. You can actually say pssh or parallel -SSH then --help, and also pscp or parallel -SCP then --help. You can see the usage is similar in nature. Both of them actually take similar type of control arguments to pass the information. Also, we have already created a file which contains the host information. The file name is nothing but this one. You can see the content of this file. There are two entries. One is related to this remote machine. Another one is related to this remote machine. Now we should be able to validate what all folders and files we have in the remote system in the home directory using pssh like this. In this case, we are trying to get from both the systems. We should be able to pass the host information using the host.txt file by using -h control argument. Then you can actually specify the location of the PEM file by saying -i, then ~/.sh, then gsdemo.pem. Then you should be able to run commands such as ls-ltr to review what we have in the target system. Now it will connect to both the systems. However, you are not able to see the output. To see the output, you have to use additional control argument. It is nothing but -i. Let me add -i here. Now you should be able to see the output. You can see that in both the systems we have data.tar as well as data. I would like to clean these things up again using pssh itself. For that, I should be able to hit up arrow. Then here I can actually say rm-rf, then data star. It will take care of deleting both folders as well as files with data prefix. Now let's run ls-ltr command once again. You can see that both data folder as well as data.tar file are gone. Now let's also clean up the scp demo and scp demo.tar. For that, I can just say rm-rf, then scp demo star. It will take care of cleaning up both folder as well as file. Now let's run ls-ltr command once again. Either of the systems doesn't have any folders or files in the home directory. As we have successfully cleaned up using pssh, before moving on to the next lecture, let me also create a folder by name data. The reason why I'm actually creating a folder by name data is because I'll be using subfolders in data to demonstrate how to copy folders into the target systems using pscp. I should be able to create data folder by saying mkdir-p, then /home/ubuntu, then data. It will take care of creating data folder. You can validate by running ls-ltr command once again. You can see the data folder here. You can also run find data to see what data contain. As of now, we have just created data folder and hence it should not contain anything. You can see the details here. As part of data, we do not have any other folders or files. That being said, as we have prepared both the target systems with data folder, let's go to the details about copying files as well as folders onto the target systems using pscp in parallel. As part of this sectional module, we are going through the details related to copying files and folders between multiple systems using SCP. At this time, we are exploring parallel SCP or pscp, which can be used to copy files to multiple systems in parallel. Already, we have successfully set up parallel SCP or pscp on this machine. Also, we have the host details as part of this file. Now we should be able to use pscp to copy files or folders onto the remote machines in parallel, you can actually get the usage or help of pscp by saying pscp -help or parallel -scp then space -help. When it comes to usage of pscp, it is similar to pssh. First, let us explore how to use pscp to copy a file from source to multiple target systems in parallel. For that, we should be able to say ls-ltr. There is a file called as data.tar. Let's try copying this onto the target systems in parallel using pscp. When it comes to usage of pscp, you can actually say pscp then -h. Then you should be able to specify the file which contain host details, which is nothing but this one. Then you can also use -x to pass the pem file name. In this case, we can pass the pem file by saying -i, then ~/.ssh, then gsdemo.pem. Then we have to specify the source file name. Either you can specify fully qualified path or relative path. In this case, I'm passing relative path for the file, which is nothing but data.tar. Now we have to specify the fully qualified path for the file on the target systems. Let's use /home/ubuntu because we are using ubuntu credentials as part of the host file, and hence we can actually specify ubuntu home directory because the user will have write permissions on this folder. Then you can optionally specify the file name, which is nothing but data.tar. If you don't specify the file name, it will use the file name that is specified here. Now let's hit enter. It will take care of copying data.tar onto both the systems in parallel. As the size of data.tar is reasonably big, it will take some time to copy. In this case, data.tar is uncompressed tarball. It is of size 3.1 GB. Now it is done. You can actually say ls-lhtr, hit enter. When it comes to data.tar, it is actually of size 631 MB, not 3.1 GB. It took some time to copy this 631 MB file onto both the systems in parallel. Let's validate whether the file is copied successfully or not. For that, we should be able to use pssh command with ls-ltr. Let's go for that command here. I have copied directly onto the home directory, and hence you can see the data.tar as part of the home directory on both the remote machines. Now let us try copying data_uncompressed.tar. It is of size 3.1 GB. And hence it will take almost 3 minutes. To speed up, we should be able to compress while copying. It will just compress the tarball while copying. The way you can achieve it is like this. You can use pscp command itself. As part of the options that are passed under -x, you should be able to add -C, which is part of scp. -C will ensure the file is compressed in transit. Once the file is copied onto the target systems, it will be automatically be uncompressed. Now let's try with data_uncompressed.tar. I would like to specify the same name on the target as well. I can actually remove the file name completely. It will take care of copying this file onto the target. Now let's hit enter. Yeah, the size of this file is close to 3.1 GB. It will take some time to copy these two target systems in parallel. Let's wait until this command is completely executed. Then we'll validate and then take it further. Now this file is copied successfully onto the target systems in parallel because of the pscp. Let's validate by running ls-ltr command. Let me go back into the history and run ls-ltr command. You should be able to see data_uncompressed.tar on both the target systems. As we have understood how to copy files onto the target systems in parallel using pscp, now it is time for us to explore how to copy folders onto the target systems in parallel using pscp. Let's go through those details as part of the next lecture. As part of the sectional module, we are going through the details related to copying files and folders between multiple systems using scp. At this time, we are exploring details about copying files and folders onto multiple systems in parallel using parallel scp or pscp. In the previous lecture, we have gone through details related to copying files onto remote machines in parallel using pscp. Now it is time for us to explore how to copy folder onto multiple systems in parallel using pscp. All you need to do is you have to add recursive to it. First, let's see the usage of pscp command or parallel scp command by saying pscp -help. If you look at the options, you have -r or --recursive to recursively copy directories onto the remote machines in parallel. In this case, we just have to improvise this by saying pscp, then -h hosts.txt. Then you should be able to specify -r to copy the folder recursively. In this case, instead of copying data folder, I'll be copying retail_db folder within a data folder. I should be able to specify the retail_db folder by saying data slash the data folder have retail_db folder, then retail_db. Then for the target, we should be able to say /home/ubuntu/data. We already have data folder in target. We have created using pssh. Now retail_db folder will be recursively copied to home Ubuntu data in the target systems. Also keep in mind that we have passed these arguments related to SCP. Because of -C, it will ensure that the files and folders related to retail_db are compressed in transit. Once the files and folders are copied to the target, they will be uncompressed automatically. Now let's hit enter. It will take care of copying the retail_db folder from source into the target systems in parallel because of the pscp command. Let's wait until it is completely executed. Then we should be able to validate by using pssh command. Let's go back to this pssh command. In this case, let's say data here. It will go to the data folder and it will display the files and folders in that location. As of now, we should be seeing retail_db folder in data. Instead of using ls-ltr, you can also use find command. It will run find against data folder in both the systems in parallel and it will show the results. Let's see the results here. Now you can see the subfolders and files related to retail_db under data in both the target systems. This is how you should be able to copy the folders in parallel onto the target systems using pscp. To make our results comfortable, let's copy another folder under data onto the remote machines using pscp in parallel. First, let's review what we have under data folder. For that, I am actually saying ls-ltr, then data. You can see that we have lca, we have nysc, we have nysc_all, we have cards, so on and so forth. Let's pick one of these folders. Let's run du-sh data. We should be able to see overall size. It is nothing but 3.1 GB. Instead of saying just data, let me say data/star. This command will give the size of each and every folder under data. Let's pick nysc folder under data. It is of size 155 megabytes. Now let's go back to the pscp command which we have used earlier. It is nothing but this one. In this case, we are going to copy nysc. So let's say data/nysc. So this is the source folder. When it comes to the target, we can specify home Ubuntu data. We don't need to specify nysc. The folder will be named as nysc itself under data folder while it is being copied. Now let's hit enter. It will take care of copying nysc folder from the source onto both the target systems in parallel. Let's wait until it is completely executed. Then we'll run ls-ltr using psh against both the systems. We'll review whether nysc is actually copied or not. After ls-ltr, we can also run find command against nysc folder under home Ubuntu data to confirm what all files we have in nysc folder in the target systems. So let's start with ls-ltr command. In this case, we can say ls-ltr data. It will actually give us what all folders and files we have under data. On top of retail_db, you can see that there is also nysc. Now we should be able to say find then data/nysc. Then we should be able to see what all files and folders we have under nysc folder in target systems. You can see the details here. nysc folder contain only a tarball and csv file. You can also validate against the source system by saying ls-ltr data nysc. Hit enter. You can see that it contains only a tarball and csv file. Both these are actually copied onto the target systems in parallel because of the pscp command. This is how you should be able to copy the folders recursively from the source systems onto the target systems in parallel using pscp. The key is you have to use -r for recursive copy. As part of this sectional module, we are going through the details related to copying files and folders between multiple systems using SCP. After going through the details about copying files and folders between one system and another system, we have also explored how to copy files from one system to multiple systems using parallel SCP or pscp. As we have understood both the scenarios, there is another common scenario which is nothing but copying files and folders in parallel between one system and another system. For that, we should understand the concept of submitting certain applications in the background. We typically use nohup for that. First, let's explore nohup in detail. Then we will see how to submit multiple SCP commands to copy files and folders between one system and another system in parallel. We are not talking about copying the files and folders from one system to multiple systems in parallel. Instead, we are talking about copying files and folders between one system to another system in parallel. You will be understanding the details by the end of next few lectures, where I will be covering all the details related to copying files and folders between two systems in parallel. As part of this external module, we are going through the details related to copying files and folders between multiple systems using SCP. At this juncture, we are talking about copying files and folders between two systems in parallel, which means we would like to submit multiple SCP commands to copy files between two systems. That being said, we should be able to leverage something called as nohup so that these SCP commands are actually submitted in the background. Let's focus on nohup. Let's understand what nohup is all about. Then we'll actually talk about submitting multiple SCP commands to copy the files and folders between the same systems in parallel. The nohup syntax will be like this: nohup, then the application name. It can be anything, it can be command also. Then you have to add ampersand at the end. Before going through the details, let's explore the important command called as sleep. Then we'll actually get into the details related to nohup. In this case, if you just say echo hello world, it will run immediately and you should be able to see the output immediately. As soon as I hit enter, I'm able to see hello world here. However, if you say sleep 3, then semicolon, then if you say echo hello world, it will sleep for 3 seconds, then you should be able to see the output hello world. You can see here, it have waited for 3 seconds. Now we are able to see hello world. Instead of 3, if you give 10, it will wait for 10 seconds. Now it is waiting for 10 seconds in the foreground itself. During these 10 seconds, I will not be able to run any other command. We have to wait until it is executed. Either we have to open another terminal and execute another command, or we have to wait until this command is completely executed. What I'm trying to convey is many times there might be certain commands or programs that might be running for a long period of time. If we just run in the foreground, we have to wait until it is completely executed to run in the same session. Otherwise, we have to open another terminal and we have to run in the other terminal in parallel. Now instead of 10, let's say 60. In this case, we have to wait until 60 seconds to actually issue another command in this session, which is not practical many times. In those scenarios where the application is taking some time to run, instead of running the applications in the foreground like this, we should be able to use nohup. Then we should be able to say sh-c in double quotes. We should be able to pass this command. As hello world is passed using double quotes in echo, let me use single quotes here. We should be able to copy paste this one. If the string is in single quotes here, we should be able to use double quotes while passing this as part of the sh-c command. Now let me hit enter to copy. Let me paste here. Let me close the single quote here. And then we have to use ampersand. It is important to have ampersand at the end. Then only the command will be executed in the background rather than in the foreground. Now you see the control is back immediately. You can actually say ps-fu to list the processes that are running by this user. At this time, there is a command by name sh-c sleep 60 echo hello world is running. It will be done after 60 seconds because we have sleep 60 here. However, the control is back. I am able to run ps-fu. I should be able to run any other command. Let's say I would like to review what all files and folders I have in this home directory. I should be able to run ls-ltr like this. You can see the files and folders without any gaps. However, if I do not use nohup with ampersand at the end, the application or command will be running in the foreground, which means you will not be able to run any other command until that command or application is completely executed. You should be able to open another session and you should be able to run in that other session, but you will not be able to run any other command in the active session where the application or command is running in foreground. Now let's run ps-fu once again to see where we stand. As of now, the application is completely executed. You can see here, when we actually use nohup, it will update nohup.out. You can actually say tail nohup.out to see the logs related to nohup. You can see the hello world here. These are the messages which are generated earlier. Because of sleep 60 echo hello world being submitted in nohup, only hello world is visible here. This is how you should be able to submit long-running commands or applications using nohup in background. The command or application should be between nohup and ampersand. Without ampersand, it will not be running in the background. Instead, it will be running in the foreground. Now, how it is relevant with respect to copying files between two systems in parallel, we should be able to enclose scp command to actually copy relevant files between two systems in the background. In that manner, we should be able to use multiple scp commands to copy mutually exclusive files between the two systems in parallel. Let's go to the details so that you understand what I'm talking about here. In the next lecture, we will see how to copy multiple set of files in parallel using SCP. We'll be enclosing SCP between nohup and ampersand so that we can issue multiple commands using the same session in parallel. At this time, we are talking about copying files and folders between multiple systems using SCP. Sometimes we might want to copy too many files from one system to another system. Using only one SCP to copy all the files might take considerable amount of time. We should be able to issue multiple SCP commands in parallel to take care of copying files from one system to another system in effective manner. As we have already seen details related to nohup to submit jobs in background, let's understand how to use nohup along with SCP to submit multiple SCP commands in parallel to copy files from one system to another system. For that, we'll be using data folder. You can see data folder here. It has several folders and files in this. Instead of copying the entire data folder at once, we'll be copying one folder at a time between this system and this one. First, let's make sure we have data folder in the target, then we'll take it further. To get data folder in target, I should be able to use ssh -i /.ssh then gsdemo.pem. Now I should be able to copy the details related to this server or instance, then paste here. Then I should be able to say mkdir /data. It will take care of creating data folder in the home folder under Ubuntu user. You can validate by using ls-ltr command or even find command. Let me use find command here. As we have just created empty folder, we should not be finding anything in that folder. I'm actually saying /data to get all the details of data folder on the remote machine. You can see that the folder doesn't contain any other files and folders. Now let's start with retail_db, which is a small folder. We can use scp command like this to copy retail_db folder to the remote data folder. You have to use -i /.ssh then gsdemo.pem. As we are going to copy the folder, we have to use -r so that the folder can be copied recursively. Then we have to specify the local folder, which is nothing but retail_db. Then we have to provide the target details, the username @ the host name. Let's copy, paste, specify the path by saying /data, which means in the home directory we have data folder. To that data folder, this retail_db folder will be copied. Now let's hit enter. It will take some time to copy this. However, keep in mind that if we open another session and run scp command to copy another folder, it will work without any issues. But opening too many sessions can be counterproductive at times. Instead of opening multiple sessions, we should be able to leverage nohup and then use ampersand at the end so that these commands run in the background. By using nohup along with scp, we should be able to issue multiple scp commands at the same time in the background. Now let's try to copy return_db_json using nohup and scp. To issue scp command in the background using nohup, the command will be like this. You have to start with nohup and end with ampersand. It is very important for you to end with ampersand. Then you have to give the standard scp command. In this case, the scp command is primarily to copy return_db_json folder recursively to the target location. The target location is nothing but this one. The target server is nothing but this one. The user using which we are trying to connect to the target is nothing but this one. That being said, now let me hit enter. It will take care of executing in the background. It is actually executing in the background. You can validate by saying tail-f nohup.out. There will be a nohup.out file in the same folder where the command is being run. It will be updated with the feedback that is generated by these commands. I think it have already ran. Let me hit Ctrl+C. It actually killed nohup.out and it came out. By the time it came out, even our original nohup command is executed. That's why we are seeing this message. That being said, the scp command is successful. You can actually say tail nohup.out. Nohup.out is not updated for some reason. That's fine, you can ignore it. Don't worry too much if it is not updated. We should be able to validate whether data folder have retail_db_json or not by using ssh command. Now let me go back to the ssh command and let me validate whether data folder contain retail_db_json or not. I'll be using ls command rather than find command. Let me say ls-ltr. Let me hit enter. You can see both the folders here. You can also say /* so that you can see the contents of these folders. These are the details related to retail_db. These are the details related to retail_db_json. That being said, as we have already seen how to use nohup to submit the scp command in the background, let's try running two nohup and scp commands in parallel. let's pick up the folders which we wanted to use. In this case, I'll be using du-sh command to see the size of the folders. Let's pick the bigger ones. We have nyc_all, which is 390 megabytes in size, and also we have lca, which is 444 megabytes in size. We can pick these two things. Also, you can pick cards, which is 1.8 GB in size. Now I should be able to use the same nohup command which you have seen earlier. Then we should be able to replace return_db_json with cards. Then run it. Now cards is being copied. Let's try nyc_all. And also lca. So we are running 3 scp commands to copy these 3 folders at the same time. They will be running in parallel. You should be able to validate while they're running by using ps-fu command. You can see all the 3 scp commands are running in parallel. Keep in mind that you might not get 3x throughput because of this. It depends upon the network bandwidth and also the system's capacity that are being used for the scp. However, it will be definitely faster than just using one thread. Now let me hit enter. By now 2 jobs are completed. It is actually running the third job, which is nothing but copying cards. You can see here lca and nyc_all are done. However, cards is not done yet. Let's use ps-fu command to see if the third one is still running. You can see that third one is still running. We have to wait until the third one is also completed. This is how you should be able to leverage nohup along with scp to submit multiple scp commands in parallel in the background. Instead of using nohup, you can also open multiple sessions and run these scp commands using multiple sessions as well. There are also tools like screens, but I'm not very comfortable with the screens. If you want, you can also explore screens, and you should be able to use one session to open multiple screens in that session and submit these jobs in parallel. Either of the approach will work. The most preferred way in my perspective is using nohup. Now the third one is also done. We should be able to validate whether all the 3 folders are successfully copied or not to the target using ssh command. Let's use the ssh command what we have seen earlier. Let me remove star here. We should be able to see 5 folders. You can see all the 5 folders here. You can also compute the size by saying du-sh here. Now we should be able to see the size of all these folders. This is actually giving the size of all the folders together. Let me add star here so that we get the sizes of the individual folders. Now we should be able to see the sizes of the individual folders. You can see cards is of size 1.8 GB, LCA is of size 444 MB, nyc_all is of size 390 MB, so on and so forth. This is how you should be able to use nohup with scp and submit multiple scp commands in parallel to speed up the scp process to copy the files and folders from one location to another location or from one server to another server. As part of the section module, we have gone through the details related to copying files onto remote machines using scp. For the demo purpose, we have actually provisioned a couple of EC2 instances. As we have gone through all the tasks related to copying files onto remote machines using scp, it is time for us to either stop these instances or terminate these instances. If you want to continue use these things for other relevant tasks, you can leave the servers stopped. If the servers are stopped, you will not be paying anything to AWS for the compute. However, there might be some nominal costs associated with the storage. It is up to you whether you want to terminate these instances or stop these instances. Whatever action you want to take, you just have to go to AWS console. In this case, I'm in the AWS console. Make sure you search the instances with the appropriate name here. Even though I have used copy demo for the demo purposes, I have already terminated those things, and hence I don't have any instances with the name copy demo. I have instances with the name Ansible demo. I have searched for Ansible demo here, and you can see that the filter is applied, and you can review the instance details here. Once you confirm that these are the instances you have used earlier, if you wanted to stop the instances, you just have to select these, go to instance state, then click on stop instance. It will take care of stopping the instances. When you stop the instances, you will not be charged for the compute. However, there might be some cost associated with the storage. You can actually select both the instances at once by clicking on this. You can see here. In case if you wanted to terminate the instances, you just have to select and then go to instance state, then click on terminate instance. Most likely the storage associated with these instances will also be released. If not, you can actually review volumes and delete the instances which are not in use at this time. However, before deleting the volumes, you need to be careful that you are actually deleting the volumes related to the instances which you are not interested in. You can go to volumes to confirm whether there is any unused storage at any point in time. That being said, You just have to select this and then go to instance state and perform the action which you are interested in. It could be stop instance or terminate instance. If you click on stop instance and if you want to start again in future, most likely the public IPv4 DNS and public IPv4 address details will change. You just have to review these details and you have to start using new details by discarding the old ones. Just keep that in mind about the impact on stopping and starting the EC2 instances. The public IPv4 DNS and public IPv4 address using which we typically connect to these instances will be changed.